Section 8.4, comparing proportions from two populations. So the difference between this section and the prior sections in Chapter 8 is that now we are going to be comparing two populations instead of just running a one proportion test. If this first example sounds familiar when I read through it, it's because we actually used this same example back in section 7.5 when we compared two different intervals with confidence intervals. And so we've already compared these two situations in the confidence interval way, and you can look back to see what we came up with for that. But this is two different Pew surveys were taken to assess America's support for stem cell research. In 2002, 43% of the Americans expressed support, and again, that's from the survey, Americans in the survey. And in 2009, 58% of those surveyed expressed support. So can we conclude that the support has changed in the population of all Americans, or could this difference just simply be due to the chance during the sampling procedure? So again, if you take two samples, especially of two completely different randomly selected groups of people this many years apart, certainly there should be expected to be some variation, even if nothing has truly changed, right? You're probably not going to get the exact same percentage both times. That we're really looking for and trying to test here, is that difference in percentages enough? Or is it different enough to say, to make that claim, that yes, the percentage really has changed from 2002 to 2009? Okay, so we have two populations. We have the 2002 and 2009. Each of those populations has a true population proportion who support stem cell research, but in each case, we don't know this true value. So I don't really know how many people for sure in 2002 supported this, and I don't know for sure how many people in 2009 did. The only numbers I know are just the sample numbers. So we have these samples, and we must predict or estimate the true proportions from these samples. Okay, it really doesn't matter which one you let be your P1 and your P2, but once you've defined them, you need to make sure you stick with that through the rest of the problem. So for us, we're going to let our P1 be the number of Americans who supported the stem cell research in 2009. We're going to let that be our P1. And we're going to let our P2 be the 2002 number. Again, we don't really care what P1 and P2 are. All we're really trying to answer is a question about their relationship to each other. So our null hypothesis is going to be that there really is no change, that P1 and P2 are the same. That's our null. Then we can write an alternate hypothesis in any three ways. So we could just say we're claiming that it has changed in some fashion so that they're not equal to each other. We might claim specifically that it has decreased. So be careful with this. If it has decreased, then that would mean that the 2009 percentage is smaller. So it would look like this, because this is 2009 and this is 2002. Or our alternate could be that it has went up, that it has increased. So again, this is just a reminder. This is the table out of your book that just explains the difference, shows the difference between those three variations as well, and reminding you that the not equal to version is two-sided and the other ones are one-sided. Okay, so now what we're going to calculate is, instead of the one proportion z statistic that we've talked about in the prior three sections, we're now calculating the two proportion z statistic. I'm not even bothering to show you the formula for this one because we will always be using StatCrunch to calculate it. It's a very, very complicated formula. Okay, here's some more data from this example. So this gives us the actual numbers. So we have the 2002 and 2009 actual values for how many supported and how many did not support. So here is the hypothesis that we're specifically going to test. We're going to go ahead and do the two-sided one. We're going to have our null be that everything's the same, and our alternate just be the statement that something is different. Now I want to make a special note here. This is how we usually write these. It makes sense for us to write like P1 equals P2 and P1 doesn't equal P2. But this is not how they show up in StatCrunch. For whatever reason, they modify them. They show them with the subtraction version. So what you're going to see in StatCrunch to match these is they're going to actually write this one as P1 minus P2 equals 0. It's the same thing. It's the same statement. If they equal each other, then you should be able to subtract them and get 0. And if they are not the same, then if you subtract them, you will not get 0. I guess the reason why it looks like this in StatCrunch is because, remember, in confidence intervals, the whole confidence interval comparison relied on, can I subtract these values and get 0? And 0 is what we were always looking for inside the interval to decide whether they could be the same or not. And our hypothesis tests are in the same area as our confidence intervals in StatCrunch, so they have to use the same formatting. Okay, so also a special note here, we are not going to check the conditions on this one. That is actually the most time-consuming part, and we're going to check the conditions on the next question. But for this one, we're going to skip that part, and we're going to go straight to the calculations. You could go back and check them. They will verify. This is a legal test that we can run here. We're going to go into StatCrunch and we're going to enter summary information because that's what we've got in this table. They've already summarized everything. They do not have a list of all 3,000 people saying yes or no to support. That would be data. But what we have right now is a summary. So for our sample 1, a reminder that's 2009, success would end up being that they did support it. So 870 out of the total 1,500. And for sample 2, the 2002 data, there were 645 who supported out of 1,500. So we're going to have to use that in our StatCrunch, and I'm just, as another reminder, again, down here, whenever you go in, your hypotheses are not going to look like this. They're going to look like P1 minus P2 equals 0, and P1 minus P2 does not equal 0. We're saying they're the same unless we can show enough evidence that they're different. And notice what we want to record. We want to record still that Z value and that P value. So I'm going to go ahead and flip over here. So same basic area, we're still going to stat proportion stats because these are still percentages. The only difference now is I go to the 2 sample. And in this case we have a summary. So I'm going to use the same information I just wrote down. So 870 out of 1,500 and 645 out of 1,500. I'm going to leave it on the hypothesis test. So my null is that when I subtract them I get 0, and my alternate is that if I subtract them I do not get 0. That's what we had. And I don't need to do anything else here. I could always do an optional graph if I want to, but I'm going to go ahead and compute it. So make note again of those very last 2 columns. That's what we really want to write down. We want to write down that z-stat and that p-value. So the z in this case was approximately 8.22, and the p was so small that they just said less than 0.0001. So now let's write up our conclusion. We're going to interpret this. It says the probability of getting an outcome as extreme or more extreme than this, than that 8.22, is this small. okay, so let's again say that one more time to yourself. Really make sure it makes sense. The probability of getting an outcome as extreme or more extreme than what just happened is extremely small. Hence, this is not likely to happen again by chance. We are surprised by this. Since the p-value is less than our stated significance level of 0.05, this is the same idea as what we've been doing all chapter long. So when it's less, we reject the null. When you reject the null, you go with the alternate. So the alternate here was that the support has changed somehow. Again, we aren't going as far in this to claim it went up or down. That was not what we were testing. All we can conclude is exactly what we tested. So we can say something like support for stem cell research changed.